Hello everyone, today we'll learn about the chapter spectrum. As you can see in the picture, there is a glass prism on which white light is allowed to fall. And when white light is allowed to fall, you can see it is split it into 7 different colors which is arranged in a definite pattern. So this pattern is known as, this band of 7 colors is known as spectrum. Okay, and children, this process of splitting of white light into 7 colors, this process is known as dispersion of light. This process is known as dispersion of light. As you can see, this glass prism is not producing color itself. It is the white light which is producing the color. Glass prism is only helping in the deviation. Okay, and it is arranged in Vibgyor pattern, and which color is deviated the most from the base, you can see violet, and which color is deviated the least, red color. Now let us see the next picture which is coming after this, children. Let us see. Now see, this is a picture in which different rays are there. So you can see a blue line is there, blue line, PQ, you can see a ray PQ is there, and the arrow is going inside. It means this ray is known as incident ray, and blue ray, that is EF, in between, it is moving parallel to the base BC of the glass prism. This is the refracted ray which is moving inside. Again the blue ray is coming out, the arrow is coming out, which is FS, you can easily see. So this is emergent ray. And children, N dash and M dash, these are the normal which is drawing on the two surfaces. And you know the angle between incident ray and normal is angle I, and the angle between normal and emergent ray is E, which is angle of emergence. Now similarly, if you move this angle back, which angle you are moving? RS ray backside and PQ rays forward. There is an angle which is called angle of deviation. Now what is the relation between angle of deviation delta, angle of the prism A, and what is I1, what is I2? I1 is angle of incidence. What is I2, children? I2 is angle of emergence. You can take E also, the symbol, and sometimes in the book the symbol is also taken as I2. So what is the relation? The relation is I1 plus I2 should be equal to A plus delta. Always remember, I1 plus I2, or you can write I plus E is equals to A plus delta, where I1 is angle, incidence angle, I2 is angle of emergence, A is the topmost angle you can see in the picture, which is angle of the prism. Here is for equilateral triangle, it is 60 degree, and deviation I already shown you in the previous slide, that is D, and here instead of D what they have taken, delta. So this is the relation, you have to always keep it in mind. Now I am coming to the next picture. Let us see. So what are the factors which affect this angle of deviation? Number 1, angle of the incidence. Now children, angle of deviation depends on certain factors. First, it depends on angle of incidence. Second, it depends on the material of the prism. Which material you are taking for making the prism, which means crown glass is there, flint glass is there, there are so many you can say glass material is there. So which material you are selecting, it depends on that also. And what is the angle of the prism? Means 60 degree angle, topmost angle you are taking, means equilateral triangle you are taking, or some other triangle you are taking, the angle of the prism will change. What color or wavelength of light is used? Okay, so which color you are throwing on the prism, what is the wavelength of the light which is throwing on the prism? So angle of deviation depend on these 4 factors: angle of the incidence, material of the prism, angle of the prism, and the color or wavelength of light used. Now how they depend, we'll see. The factors on which the angle of deviation depends are angle of incidence, as we have done. How it depends? Directly proportional, means more is the angle of deviation, more is the angle of incidence, more is the angle of deviation, means directly proportional. Refractive index, children, I told you, like, it depends on the material of the prism. It depends, material means refractive index you will check of the prism, which is directly proportional to the angle of deviation, means if the refractive index is more of that material, more will be the angle of deviation. Wavelength of the light, how wavelength? Wavelength of the light passing through, inversely proportional to the angle of deviation. It means if wavelength is more, with the light which is incident on the prism, if wavelength is more, the angle of deviation will be less. Wavelength of the light is more which is falling on the prism, the angle of deviation will be less. And while the other factors are directly proportional. Okay, so always remember how the angle of deviation depends on these factors. Now we can see in this slide, two prism are kept. One is straight and the other one is inverted. Why it is inverted? If you again want the white light to be collected, and again you want a white light back, so it is that procedure. As in the first figure, you can see the first, when white light is thrown on the first surface of the first prism, and it is getting, you can see the 7 colors are outside outside the PR, you can see 7 colors are there. Again, inverted side prism is there, q dash p dash, you can check. So when these 7 colors are falling on the first surface of the second prism, which is q dash p dash, they are throwing the 7 colors on that side, and it is collected where, beta? It is collected on the second side of the second prism, which is p dash r dash, and you can see here all the colors are combined, and at last white light again you have obtained. This is known as recombination of colors. Now this is electromagnetic spectrum, children. What is electromagnetic spectrum? It has a band of various waves. Radio waves are there, microwaves are there, infrared are there, visible light is there, ultraviolet is there, x-rays is there, and gamma rays is there. Okay, now what is visible? The light which is visible to us, like violet color, Vibgyor pattern. You can see Vibgyor, violet, indigo, orange, green, or yellow. These are the colors which we can see, and the ranges is 4000 angstrom to 8000 angstrom. Now beyond the red color, because it is starting as Vibgyor R, so beyond R you get infrared, and this after that violet, what do you get, beta? Ultraviolet, and after ultraviolet x-rays are coming, gamma rays are coming, and after infrared you can check microwaves are there, radio waves are there. So you can see the utilities also mentioned there, remote control, bulb, microwaves, radio waves for communication. Now comes what is scattering of light. So children, as you know, when sunlight is coming through the atmosphere, the dust particles are present there. They collide with the dust particles, and these particles get scattered. So this process is known as scattering of light. Okay, so scattering of light is the dispersion. It is a kind of dispersion of that scattered the particles by the presence of the sunlight, which is entering and colliding with the dust particles. So light moving in all direction after colliding with the particles. Fog is a very good example of scattering of light, allows you to see the outside beam, but it dims the light also. Now, why the sky is blue? As you know, why? Because blue color has the shorter wavelength and it scatter more. The color which scatter more, always remember children, it will be blue. It will give you that color which scatter more. So blue is the color of the sky. This is the reason. Now, again it is there. As sunlight moves through the atmosphere, longer wavelength is which color? Red color has the longest wavelength. It straight pass through. So the sky will not get this color. Which color scatter more? As I told you, shorter wavelength. And which color has the shorter wavelength? Blue color is having the shorter wavelength. It interacts with the gas molecule and it scatters in the atmosphere. So at last, what you get? You get sky as a blue in color. So this is due to the scattering effect. Okay, so always remember what is the reason? Scattering of light is the reason behind the bluish color of the sky. So why? You will always write blue color has the shortest wavelength, it scatter more. Red color has longest wavelength, it scatter least. That is why red color is passed as it is. It will not scatter. Now I'll coming to the next example, which is this. Secret of why during sunrise and sunset we appears that sun is red in color. Why? Because during the sunrise and sunset, the sun has to cover a longer distance to reach to the observer. Observer means we are standing on the earth. Suppose it will take a longer distance. The light is taking a longer distance to come from sun to the earth. So as the sun approaches the horizon during the sunset, sunlight has to travel a longer distance to reach our eyes. Hence, light with shorter wavelength. What is the light of shorter wavelength? We know, which is the blue color. So it gets scattered. Okay, and which color is left? So red color is left and it has the longest wavelength. So it reaches our eyes, and in this way children, during the sunrise and sunset, you get what color? You get only the red color and not the blue color, because the blue colors get scattered all over and red color we get. Now next, this is the, you can see the observer sees the blue color from all directions. Now many times you have seen that astronaut goes to the space, he see that the space, the sky is black in color, but he sees from there that the color of the sky, the color of the earth is blue. Why? Because as I told you, when the astronaut is going in the upper atmosphere, there is no atmosphere. If you know, in the space there is no atmosphere. If no atmosphere is there, no scattering will be there, so black color you will get. Now when he sees the earth, and you know the shorter wavelength, it scatter more, and which is the shorter wavelength? Blue color. So that is why for the astronaut the sky, the earth appears as blue in color. So this is all about a short which we have discussed the various applications also of scattering of effect. So hope you have understood. Thank you very much children. So thanks.